A very good evening to Dr. Zaini and all my fellow friends. Today we're gonna present our project presentation from Group 1 of Computer Programming BDA 24202. So before we start our presentation, I want to introduce myself and also my team member, which is the first one is Abdul Wafi bin Abdul Halim. Second one is Elron Fresher Gronica, which is me and also as a group leader. And last one is Gopinathan Anak Lelaki Subramanian. So, first of all, the introduction. Operating conventional machines are full of challenges such as difficult to estimate the part of machining time, total energy consumption, total operation cost by products or solid waste generation, and estimate productivity per day. My team is assigned to assist Super Metal Company to improve their product planning. My team has developed 3 programs to guide their operator in using conventional machine for selected metal parts in the lathe machine, milling machine, and also a drilling machine. Next one is machine specification, part design, operational analysis. So we go for the first one, which is the basic information for milling machine. The model is PYA CNC 2500, which is this is the new condition and the weight is about 12 tons. Next one is Lathe Machine. Lathe Machine is the model that we use is CO632B over 1000, which is the spindle bore is 38 millimeters. The width of bed is 186 meter, and also the maximum length of workpiece, the capacity is about 1000 millimeter. For drilling machine, this is the basic information that we get, which is the model number is BP5, and the number of spindle speed is 8. The range speed that we can use for this machine is 590 to 1080 revolution per minute. So the power of the drilling machine, the maximum is about 1440 RPM. So this is the specification of the drilling capacity in steel is about 20 millimeter. Drilling capacity in cast iron is about 25 millimeter, and others for tapping capacity in cast iron is 3 to 12 and also 15 millimeter respectively. Next, we go to our design part, which is this is the figure. So here is about the product design that produced by the machine. For milling machine, especially for milling machine here, we have this plate with a hole, which means the final product of the lathe machine is there's a hole above this mild steel or this kind of workpiece. So this is the process of the design, which is for milling machine. If you want to create a same depth you need to using the specialized drill bit, which is around 3 millimeter diameter, and the conical flow of the drill bit must be 135 degree. For milling machine, from lathe machine, the design part we actually use for the chucking process about 1.5 inches long, and the cutting process, we use the correct speed to cut the surface of the workpiece. For milling machine, the speed for the operation we took around 150 to 250 revolution per minute. So this one is the steps. The operational steps of the machine. First one is the milling machine. For milling machine, we have 6 steps, including fit the workpiece in the direct opposite of the rotation of the milling cutter, and after that we adjust the milling machine if the workpiece cannot held in the certain speed. So from the 6 steps here, the important part is need to select the slot milling cutter of the size of the T slot that we need to be cut so that we can have a correct dimension. Next one, lathe machine. Lathe machine, we have two different operational procedure, which is rough turning and also straight turning. For rough turning, we have 7 steps, including we need to keep the tool holder from slipping, which is this is the most part, is the important part for the rough turning. So for straight turning, we have 10 steps. The important step here is adjust the turning speed and the revolution about 2/3 of the maximum speed. And also for the drilling machine, we have 6 steps. So in these 6 steps, the important things that we need to do is for the tapping process, the drilling machine should be equipped with the reversible motor. So next will be my friend Gopinathan. Please welcome.
Okay, good evening, doctor and my fellow friends. Okay, my name is Gopinathan Subramania. My material number is CED200153. Okay, next I want to present about the programming flowchart for drilling machine. So this is our flowchart. So start until we have end. So next. Okay, for drilling machine we have 7 steps. Okay, these are the algorithm for drilling machine. So let's see step 1. Step 1 is turn on the drilling machine. Step 2 is determine the raw material of dimension. Step 3, if diameter is 19 mm, calculate the machining time. Step 4 is calculate the total energy of consumptions. Step 5, calculate the solid waste generation. Step 6, calculate the productivity for 8 hours. And the last step is determine the output for machining time and total energy consumption, solid waste generation, and productivity for 8 hours and power input. Okay, for the next machine we see about the lathe machine. So these are our flowchart for lathe machine. And then we go next, bro. Okay, next. Okay, these are the algorithm for lathe machine. For lathe machine we have 8 steps. So first step, we turn on the lathe machine. Step 2, determine the row of dimension for the workpiece. Step 3, determine whether the D is below than D naught and length is below than length naught. Step 4, if D below than D naught and length below than length naught, calculate the milling and calculate the machining of the time. Step 5, calculate the total energy for the consumption. Step 6, calculate the solid waste generation and the productivity. Step 7, display the output. And the last step, we end for the next. Okay, next we see about the milling machine. Okay, these are our flowchart for milling machine. Here we have start until end. Okay, next we see about our steps for milling machine. Here we have 7 steps. So for the first steps, we turn on the milling machine. Second step, determine the cutting speed for each hole diameter range. Step 3, determine the size of the mild steel workpiece, include thickness, length and width. Step 4, insert the parameter. Step 5, calculate the value of Y, H, A, R, D, I, G and P, Q and V using the suitable formula. Step 6, the output of the calculation was determined and it shows whether the output is error or not. The last step is the operation is end. So the machine is switch off. Okay, next we go for the programming codes. Here we have the complete programming codes. Okay, let's see about our first machine is milling machine complete programming codes. Here we have three diagrams, three figures. Our for milling machines complete programming codes. So here we have step 1 until step 7 as I mentioned before this. Okay, next we see about the Lathe Machine for complete programming codes. Here we have two figure. So here we have step 1 until step 8 for the lathe machine. Before this I present. Okay, next we see about the drilling machine. Okay, for drilling machine also we have two figure and include with the 7 step. Before this I present the steps for complete the programmings. Okay, next. Okay, this is the coding output demonstration by using our software dev cc plus. Okay, these are the output coding for drilling machine. So for the machining time is 0.36 minute. So total energy consumption we get 189858 4.88 kilowatt. So solid waste generation is 226.22 millimeter per cube, and the productivity per 8 hours is 170.67 unit. So process exit after 32.68 second with return with value of 0. So next we see about the output coding for lathe machine. So here we see about the machining time is 0.828 minute. Total energy consumption. Yeah, so we 29398278.00 kilowatt. So solid waste generation 146260.09 millimeter per cube. So productivity per 8 hours is 136.12 unit. So okay, next we see about the output coding for milling machine. So for milling machine, so we got about please try again machining. So we got timing is 0. So scrap generate in kg was 2147483648. So output per day is we get 0. So efficiency we get 1.0000 per energy utilization for 8 hours equal to 4.0 kilowatt. So these are the our programming steps, codes, flowchart, and our output. So next, my friend Wafi will present out about the calculation formula and equation. Thank you.
Assalamualaikum and good evening. My name is Abdul Wafi Alim. My meeting number is 819024. I will present about calculation formula and equation. First, we get lathe machine calculation. The first process is machining time. Tm equal to L over Fr. We get 0.22 minutes. And for the MRR equal to MR multiplied by F, we get 1.95 multiplied by 10 power of negative 4. And for MRR multiplied by unit power, we get 293.98278 kilowatt. The next process is total energy consumption is equal to pi multiplied by d power of 2 multiplied by dc equal to 191.0. For productivity in 8 hours, dm multiplied by 8 hours multiplied by 60 millimeter, we get 105.6 unit. Next, we get the drilling machine calculation. For drilling machine, first process is machining time. Dm equal to L over Fr. We get 0.32 minutes. For MRR equal to MR multiplied by F. We get 1.27 power multiplied by 10 power of negative 8. And for MRR multiplied by unit power, we get 1.76 multiplied by 10 power of negative 3. And for the next step, total energy consumption We get pi multiplied by d power of 2 multiplied by dc. We get 339.292. And for the last one, productivity in 8 hours, we get TM multiplied by 8 hours multiplied by 60 millimeter. We get 153.6 unit. Next, the last one for the milling machine calculation, there is two steps, which is cutting time and cutting speed. For the cutting time is T equal to 60 multiplied by DE multiplied by 40 and over 1000 multiplied by BC and multiplied by F. We get 2.27 minutes. For cutting speed, BC equal to pi multiplied by D multiplied by N over 1000. We get 130.097. Next. For the conclusion, firstly, we understand the conventional machine and its operation in supernatal. Next, we purpose three-part machine design. Then, we purpose the step involved to the machine a raw material until get a purpose part design. Furthermore, from the suggested, we have developed three complete programs to assist the operator in machining operation planning. Lastly, our program show the detailed step and the parameter and correct calculation to the machine raw material. Next.
That's all from us. Thank you.
Thank you.